I want to finish up today with a quick few observations about the size of a matrix and where things come from in the equation, the matrix equation AX equals B. So let's suppose that A is an M by N matrix. M by N is the standard way to decide on the size of a matrix. We use N for index because I is spoken for, but M and N are terrible choices for the size of a matrix because they both kind of It'd be like when you have name all your variables that all just sound like E. Like here's B, D, E, G. And you got to get that consonant sound at the beginning because everything's just like all E. But anyway, that's an English problem. That's and too many letters sound the same problem. I could have gone with P and Q because there's that E and the U, and then they actually sound different. But we're stuck with M and N. So I'm just going to have to learn to enunciate properly. Let's suppose that A is an M by N matrix. That means we have M rows and N columns. What we want to point out is the sizes of the X and the B in the equation AX equals B. So in the equation AX equals B, B is going to be the same as the size as the columns of A. So B is going to be from RM. B is the same size as the columns of A. But X will come from Rn, because to make the product AX defined, we have to have an entry in X for every column of A. So X is going to be in Rn. So the number of columns of A must equal the number of rows of X for the matrix product to be defined. And the result will have the same number of entries as the columns of A. Remember, this question might be asking, is B a linear combination of the columns of A? If that's the case, then B has to be the same size as the columns of A, because you can't take a bunch of vectors from R3 and build a vector in R4. That's not how this works. So in the matrix equation, AX equals B, if A is M by N, we can multiply by X if X is N by 1, and the result will be M by 1. So the two in the middle have to match. That's to make sure the product is defined. And then the result will be M by 1. So this is just an important thing to note about the sizes of entries. This came up in one of the quizzes because A was a 3 by 2 matrix. So if A is 3 by 2, if A is 3 by 2, then x has to be, as a vector, 2 by 1, and the result will be 3 by 1. So if I ask you to solve the equation ax equals b and x is 2 by 1, and a is 3 by 2, then your solutions will be 2 by 1. Make sure you know the size of the thing that you're looking for. Any questions? All right, our next big topic is going to be linear transformations. So this is in 1.8 and 1.9. We're going to tie linear transformations to matrix multiplication. We're going to define what linear transformations are, but linear transformations are just going to be defined by matrix multiplication. So we're just going to be taking new concepts and dropping them onto old ideas. We're just expanding what we already know. This is the way in linear algebra. Make everything the same. Any questions before we adjourn for the week? All right, that's going to do it for today. That's going to do it for this week. Everybody have a nice weekend. Actually, I know you're not going to have a nice weekend because I've just assigned some homework and I haven't told you about how to do the homework. I'm saying, oh, hey, start working on some linear transformations. And you're like, oh, great. What are linear transformations? And I'm like, oh, bye. So I realize it's terrible that I'm making you read a math book. Oof. My cruelty clearly knows no bounds. All right, that's going to do it for today. That's going to do it for this week. Everybody have a good weekend, and thanks for playing.